You've seen some of this before, so I can be fairly quick about it. I will talk mainly about the science. I've delivered myself of some comments on the politics earlier this morning. As you know, the IPCC and NIPCC are very much opposed to each other. We would like to know, of course, who's right, and we're engaged in a substantial debate right now. I'm okay. Yeah. You know that NIPCC is non-governmental and independent. Joe Bass has already explained our background, and you've seen the full report by Craig Itzo and myself, which was just published. The main thing about IPCC is that we don't see any evidence for anthropogenic global warming. The 20th century certainly is not the warmest in 1,000 years. Ice glacier melting is inconclusive, doesn't tell you what the cause is. We don't see any unusual weather. There's no correlation between temperature and CO2, and sea level rise has been normal and not unusual. The main problem, as you've already heard earlier this morning from Dick Lindzen and others, is that models cannot reproduce the 20th century temperatures. So models and observations are in disagreement, and then matter of question, do you believe in the models or do you believe in the atmosphere? I think that's the basic division in the scientific community, and I think you all know where I stand. There are a number of disputed unsolved problems. This gives lie to the statement, I think first announced by Al Gore, that the science is settled. He announced that some 15 years ago, and he's been saying this from time to time, and it's not true. The science is not settled. Climate sensitivity is on its way to being settled, thanks to the efforts of several people who are here in the audience, including Lord Monkton and others. You've heard also from Dick Lindzen this morning. Climate sensitivity, according to IPCC, is 3 degrees. According to other estimates, it could be as low as 0.3 degrees. That's a factor of 10 difference. That's big. The question is, why do the models not reproduce what's observed? And the answer is there must be feedback, and there are various kinds of feedbacks. And I must tell you that we haven't yet settled which kind of feedback from water is responsible for the negative feedback that must exist. There are several possibilities, and we have to rely on the analysis of data, and perhaps Roy Spencer will tell us more about that later this morning or today, later this afternoon. Natural forcing is obviously the cause, or the main cause of climate change, and it could be either internal oscillations and or solar. I tend to believe that you cannot have two separate mechanisms for climate change, and I favor the solar. I note here that the pioneering work was done many years ago by Bob Jastrow, who's no longer with us, Sally Balyunas, but we have Willie Soon here, who will probably touch on this. He's one of the pioneers in the issue of solar effects on the climate. We have a question about whether warming will continue if, in fact, we stabilize greenhouse gases in the atmosphere. There's a division of opinion here. I don't know the answer. You heard about surface temperatures just now. I will just add that what Anthony Watts discussed was mainly the misplacement of surface stations. There is, in addition to this, the historic knowledge of what's called the urban heat island effect. Just locally here, take Dulles Airport, my local airport out in Virginia. That used to be out in the boondocks. Now there's a big city built around Dulles. Planes are landing every few seconds. Runways have been added. All of this adds to warming. And it's very difficult to subtract this urban heat island effect, which depends on population, economic activity, and so on, from a true global effect caused by, let's say, natural forcing. So what is being measured mainly these days is temperatures at airports, where, of course, you need to have good weather stations, and the best stations are internationally located at airports. And I will readily admit that airports are warming. Yes, that's probably true. But that doesn't say anything about global warming. It doesn't tell you anything that would be useful in the current debate. CO2 residence time, according to some estimates, is 5 years. According to others, it's more than 3,000 years. That means if you suddenly were to stop emitting carbon dioxide, how quickly will the level of CO2 come back to the pre-industrial level? That is the question, not really settled. Abrupt climate change, this is an issue that I'm currently working on. Why do we see abrupt climate changes, large ones, during the ice ages, where they were first discovered? And why don't we see them now during the Holocene, in the warm period? What is it about the cold periods, the glaciations, that favors abrupt climate change? That's an interesting scientific question. And finally, we have number 8, sea level rise. Has it been rising at a constant rate, or has it been accelerating? There's a debate on that, but I think the data favor constant acceleration, constant rate of rise, and no acceleration. This is a slide that I owe to Ken Hapola. It shows how the IPCC has departed from its earlier, let's see if I can find it. Yeah, here we go. This was an earlier IPCC report showing the medieval warm period and the Little Ice Age, and then this is from the third report where these were suddenly abolished, and we went to the so-called hockey stick. They've now abandoned the hockey stick, and I think we're back to admitting that there is a medieval warm period and there is a Little Ice Age. We've never doubted that, actually. This is a slide which I owe to Joe DeLeo, and it shows very graphically the situation in the last 10 years with temperatures decreasing and CO2 increasing. So the correlation is negative. It's sometimes positive and sometimes negative, which means it's meaningless. You cannot rely on correlation to tell you anything about the cause of warming. These are satellite data, which are probably the only good data we have, unaffected by local surface effects. And this shows the temperature change over the last 10 years, from 1978, or last 30 years. I'll get it straight. 30 years, from 78 to the present. And you'll see that the Antarctic has cooled, contrary to what climate models would tell you. Nothing very exciting was happening. Most of the globe showed very little change in the last 30 years. We tend to rely on the fingerprint test. The fingerprint test looks at patterns of warming, and we all agree, that is IPCC and NIPCC agree, that fingerprint test is what we want. That will tell us whether there is an appreciable human influence. So we agree on the method, on the methodology. We disagree on the results. What I've done, using a report, a government report, is to take the theoretical values, which show the model values, which show a hot spot over the equator at, let's see, altitudes of around 10 kilometers, and compare it with what's actually observed. No hot spot, just the opposite. So here's a good example where models and observations completely disagree. Just once more, just so you can see it. This can also be presented in a different form, which Douglas has published, Christie and Pearson and myself. You see the models show an increase in temperature trend with altitude. The observations show a decrease. Another subject that's hotly disputed. You might be interested in knowing what are the objections of the other side. How do they object to that? Well, they say, maybe there's something wrong with the observations. Trouble is, we took their observations. We didn't add anything, change anything. We took the observations as published by the IPCC. Natural forcing, solar forcing, volcanism, and finally internal forcing. Those oscillations of the atmosphere-ocean system. Which is it? Well, volcanism we know exists, there's no question of that. So the question really is about solar forcing. Is it total solar irradiance? Is it solar activity, including the solar wind and cosmic rays? That is a question that needs to be settled. It's still under some debate. I personally feel fairly certain that the cosmic rays, solar activity and cosmic rays, are the primary effect on climate, as discussed in some detail by the Danish astrophysicist Henrik Svensmark, and I tend to support his view, largely based on this extremely good correlation between carbon-14, which expresses solar activity, and oxygen-18, which expresses climate. Look at this. Just look at this. We know that our Earth's climate cannot affect the sun. It must be the sun affecting us. So this is published work. It shows a period of over 3,000 years with detailed correlation between solar activity and climate. Sea level rise, well, you know, there has been a lot of discussion on this. Al Gore is famous for claiming sea level will rise by 20 feet, 600 centimeters, by 2100. Sometimes he says 80 feet. Doesn't matter, you know. It's all nonsense. It's probably going to rise, continue to rise, as it has been for the last hundreds of years, at the rate of 18 centimeters, that's 7 inches, per century. So I fully expect that by 2100, sea level will be 18 centimeters higher, which means there will be no net increase over the ongoing rate. Zilch, zero. The important clue in all of this is there has been no acceleration in the past 3,000 years in spite of temperature changes. But why is that? That needs to be explained. Let me show you the IPCC estimates. They're kind of fun. This is what they predicted for 2100 in their first report. Something's happened here.
The big one is easier.
Big one right there. Big
What?
black one right there.
Okay.
It's a whole lot easier.
Maybe this is
Press
stronger.
the button.
Big one.
Ah, that's one works. Here's what they predicted in 1990. Here's what they predicted in 1995. Here's what they predicted in 2001. And the most recent report, depending whether you take the draft, you remember the draft, or you take the final report, is somewhere around here. They've been coming down. Here's Jim Hansen. He's a contrarian. What can I say? I mean, he's a skeptic of the IPCC. Well, so are we. Okay. As you know, the climate is currently cooling. It will probably continue to cool for another couple of decades, perhaps, and then it may warm again, then it may cool again. Natural fluctuations are controlling the climate. And our little friends are freezing. I think this is probably a good place to stop, but I do want you to see once more, just once more, the great quote from Chairman Henry Waxman. in the interview on PBS, I say here, this is a gem worthy of George Bush. We're seeing the reality of a lot of the North Pole starting to evaporate, and we could get to a tipping point. He's picked up all those great words from Al Gore. Because if it evaporates to a certain point, they have lanes now where ships can go that couldn't ever sail through before. And if it gets to a point where it evaporates too much, there's a lot of tundra that's being held down by that ice cap. On this happy note, I would like to stop. Thank you.